Hello students, welcome to our online open class. Next, we are going to learn about the second operation of program design for cavity type parts. It is the finishing machining of the part contour. Finishing machining is carried out on the basis of rough machining. In this process, we used the UG automatic programming for area and contour milling. Most importantly, we should pay attention to the specified cutting area. As for the drive method of the tool, we should choose area milling, steep spatial range, and both steep and non-steep options. We should set cutting parameters in the toolpath settings as done milling and automatic with a higher spindle speed and a lower feed rate. The programming steps are as follows. First, create an operation. We should use the area contour milling method, specify the cutting area, choose the driving method. Set the tool path. Second, simulate the machining process. Please refer to the skill operation for details. We now begin the skill operation for the external contour fine machining process. Click on Geometry. Right-click to find Insert, and select Process, followed by Contour Air Milling. Choose a 16 mm diameter tool and select Geometry B for the Define Machining process. Enter External Contour Fine Machining Process as the name and click OK. Click Specify Cutting Area and pick the surface. Select all external contours. Due to the large number of surfaces, it's advisable not to use the box selection method. This is labor-intensive. Use the middle mouse button for flexible reverse selection of hard-to-reach surfaces. Switch to the side view and click OK. Choose the area milling method. Edit parameters. Select steep and non-steep. Choose Follow Perimeter. Set contour step as constant parameter with a maximum step of either 0.1 or 0.2 mm. Set steep cutting mode to reciprocating depth machining with constant depth cutting layers and a cutting depth of 0.2 mm. Then click OK. Then set non-cutting parameters with entry and exit both chosen as arc entry and exit, and click OK. Adjust feed rate and speed, keeping the spindle speed for the 16 mm diameter tool at 2000 and setting the feed rate to 700. Calculate and click OK. Click Generate to Computer and generate the tool path. Then click OK. Click on the process, right-click to find tool path and select OK. Then enter 3D Dynamic. Set the animation speed to 4 and start playing. For milling external contours to avoid marks at entry and exit. It's best to use a tangential entry and exit method. In the contour area milling cutting parameter expansion path, be sure to select Roll tool on edge. Simulation machining in CAM systems cannot complete tool wear analysis. If the entire toolpath involves an area of the cutting range, that should not be machined. Use the trim geometry parameter to move this part of the toolpath. In contour area milling, when setting the boundary drive method, the toolpath and the cutting method should be chosen as inward in a sequential manner. The animation speed to the position of 4 to start playing. After the animation finishes, click OK. Right-click to find post-processing. Select the corresponding post-processing file. Set to metric or imperial and click OK twice. Overwrite the original file to produce the machining program. We can modify and optimize the program according to the requirements of the equipment. The skew operation is now complete. Different driving methods of area contour milling are as follows. 1. Curves or points. Spiral. Boundary driving. Area milling. Surface. Radial cutting. Root clearing. 7 types of driving methods. 2. Strategy. Safety settings. Non-cutting movement. Thumping. Navigator. 4 types of cutting parameter settings. Today we completed the second process of cavity part program design on the UG software platform. During the programming process, we used the area contour milling method. You can practice on your own following the operation demonstration and correctly set the cut parameters. The finishing machining allowance is set to 0 by default. Now, if you are technicians, please set parameters reasonably and optimize them in the program. Apply this knowledge to other similar product program designs. Thank you for listening.